As a first step towards understanding Git, it is very important to understand basic Git terminologies. These terms become the building blocks to understand the branching strategies, merge options, and various other advanced features you would learn during the rest of the course. In fact, as a Scrum Master, some of the keywords you would have already heard day in and day out in your daily stand ups, retrospective meetings, or other Scrum ceremonies. For example, your developers quite often give you updates as we need to merge the code manually before we can deploy. I am unable to pull the latest code from the repository. I have lost all my changes due to recent merge from another developer, so on and so forth. This section will help you understand such trivial scenarios in more detail. The first term you will hear quite often is repo or a repository. A repo is a collection of files that you want to track and manage changes across the team. Typically, the source code of your project will be part of the repository. On the local machine, the Git repository is created as a .git folder in the root of the source code and contains all the metadata of the files modified, added, deleted, and the files ignored to track and other key information stored to provide the required source control features. We hear a lot about cloning. Git clone refers to the operation wherein a target repository is cloned or copied to the current folder on the local system. Once the clone is done, the developer can go ahead with his changes for the features or the bug he has been working on. Next, we see about a branch. A branch is a pointer to the snapshot or an independent copy of the code of the repository. A new branch is generally created for a new feature or a bug fix. As we see later in the course, it is a best practice to create a new branch for every change your team is working on. Unlike other version control systems, Git allows to create a new branch on the server and also on the local system. As you can see here, I have a copy of the code called Sprint 1. Now, I can go ahead and create two new branches, feature 1 and feature 2. Remember, these two branches I have created are on the server. Now, a developer working on feature 1 can clone the branch and start making the changes. Next, the developer can create two new branches, API and UI changes. Remember, these are local branches which are not available on the server. Now, developer can now do all the API related changes independent of the UI and without affecting other developers' work. We learn about checkout. Git checkout is performed whenever one wants to move the Git reference from branch A to branch B. When we check out, the local file folders or the files will be replaced with the branch B changes. As you can see here, I have the same branching structure created previously. Now, in this case, developer has cloned feature 1 and is currently working on the related changes. Let's say you ask the developer to start working on feature 2. Then the developer would check out feature 2 branch and go ahead. Note that at the time of checkout, any pending changes would either need to be reverted or stored for later use. We will learn more about this later in the course. Remember, while working on feature 1, the developer can check out the local branches, API changes, or the UI changes to work on the corresponding changes without having to go to the remote server. Now we see about pull. Git pull refers to an operation wherein the local copy of the repository is updated with new changes done by other members. Going back to our feature 1 branch, as you can see, the developer has cloned the feature 1 branch and began to do the required changes. During this period, the other developers have done few more changes and updated the repository. Now, in order to ensure the developer has the latest code, he will pull the code from the server repository to the local repository. If there are any pending changes done in the same source files, the command would merge the code and update the local repository. If there are conflicts in the merge, it would prompt the developer to fix the conflicts before completing the pull. Next, we see how does a developer move his local changes to a server. Commit is an operation to save your changes to a local repository. Unlike the centralized version control system, a commit in Git do not automatically update the server repository. As you can see, the developer has a local copy of feature 1 branch. During the development of his feature, he has done multiple changes and saved them to the local repository as a commit. When the developer completes the feature, he would then push the code to the server. Push is an operation where single or multiple commits are updated to the server repository. Generally, it is a good practice to do a pull before a push to avoid any loss of code or merge issues. Now, we will look at one of the important terms of Git and the one which we will be using quite often in this course going forward. Pull request is an operation to move or merge the code from branch B to branch A. Note that in the case of a pull request, the merge would not happen automatically but wait for it to be approved. A developer can raise a pull request and add one or more reviewers to review the changes before merging the code. At this point, the reviewers can look at the changes done, provide the feedback, and do additional commits to ensure the code is the way it was expected. Then the pull request can be approved for the code to be merged. As a Scrum Master, you have to look at enabling the pull request approach to ensure the quality and stability of the application is intact, especially when multiple code changes are being pushed every day. Look at another Git command, fork. Fork is generally popular with the open source projects, allowing any developer to fork or replicate an existing repository for any changes related to a feature or a bug without needing to get permission to the main repository. You can think of fork as a server-side clone of the repository. Once the changes are done by the developer can raise the pull request to move the code from the forked repository to the main repository. Note that the forked repo operations such as clone, pull, push, etc. are applicable as well. If you look at is git stash. Git stash is commonly used by the developers before a checkout command, especially when checking out a new branch while the developer is in middle of another feature or the changes, but not yet ready to commit or push the code. Stash command basically takes local changes done to the source files and back it up as a first in last out stack. Stash command is executed on the developer machine and do not update the server repo with any details. Developer can anytime retrieve the stash changes using the stash apply command. Remember, the stash apply would pick up the last set of changes pushed to the stack.